Have you ever noticed how lines and angles are everywhere? Look around you. Lines and angles make up the shapes we see every day. A line is like a straight path that goes on forever in both directions. Think of a road stretching out with no end in sight. That's a line. An angle is formed when two lines meet at a point, kind of like a corner. Imagine opening a book. The two covers meeting form an angle. Lines and angles are the basic ingredients for building all sorts of shapes, from simple squares to complicated starbursts. Let's explore the exciting world of lines and angles together. Angles come in different sizes, just like pizzas come in different sizes. Let's learn about the different types of angles. An acute angle is like a tiny slice of pizza, less than 90 degrees. It's small and cute. A right angle is like a perfect corner of a square, exactly 90 degrees. Think of the corner of a book or a piece of paper. An obtuse angle is like a big slice of pizza, greater than 90 degrees but less than 180 degrees. It's bigger than a right angle but not quite a straight line. A straight angle is like a straight line, exactly 180 degrees. Think of the hands of a clock when it's 6 o'clock. A reflex angle is like a slice of pizza that's bigger than half the pizza, greater than 180 degrees. It's like an obtuse angle went into a stretching contest and won. A full rotation is a whole circle, 360 degrees. Imagine spinning around once. That's a full rotation. Understanding the different types of angles helps us describe and measure the world around us. Just like people, lines can have different relationships too. Let's meet some special pairs of lines. Parallel lines are like two straight roads that never meet, no matter how far they go. They always stay the same distance apart. Perpendicular lines are like they're always in a hurry to cross paths. They meet at a perfect right angle, like the letter L. Think of the corner of a picture frame. Sometimes a line might decide to cut across a pair of parallel lines. We call this line a transversal. Think of it like a bridge connecting two parallel roads. When a transversal crosses parallel lines, it creates some special angles that are equal to each other. These angles have long names, but they're easy to understand. Corresponding angles are angles that are in the same position, but on different lines. Imagine them as twins on opposite sides of the street. Alternate interior angles are like secret agents hiding inside the parallel lines on opposite sides of the transversal. Alternate exterior angles are like the cool kids hanging out outside the parallel lines, on opposite sides of the transversal. Co-interior angles are like neighbors living on the same street between the parallel lines on the same side of the transversal. These special angle relationships help us solve all sorts of geometry puzzles and understand the world around us better. Section 4. Measuring and drawing angles. Become an angle architect. Now that we know about different types of angles, let's learn how to measure and draw them. To measure angles, we use a handy tool called a protractor. A protractor is like a half-circle ruler with degrees marked on it. To measure an angle, we line up the protractor's center with the angle's vertex, the point where the lines meet, and the zero line with one of the angle's sides. Then we read the degree measurement where the other side of the angle crosses the protractor. To draw an angle, we can use a protractor and a ruler. First, we draw a straight line using the ruler. This will be one side of our angle. Then, we place the protractor's center on the end point of our line, lining up the zero line with the line we drew. Next, we make a small mark at the desired angle measurement on the protractor. Finally, we use the ruler to draw a straight line from the end point of our first line to the mark we made, creating our angle. With a little practice, you'll be measuring and drawing angles like a pro. Section 5. Triangles and Beyond. Why angles matter in the real world. Angles are everywhere, from the shapes of buildings to the designs on your clothes. One of the most important places we find angles is in triangles. A triangle is a shape with 3 sides and 3 angles. Here's a cool fact. The 3 angles inside any triangle always add up to 180 degrees. This is called the triangle angle sum theorem. Knowing this theorem can help us solve problems like finding the missing angle in a triangle if we know the other 2 angles. For example, if one angle in a triangle is 60 degrees and another angle is 80 degrees, we can find the third angle by subtracting the sum of those angles from 180 degrees. 180 minus 60 minus 80 equals 40 degrees. Angles are essential in many real-world applications. Architects use angles to design buildings that are strong and stable. Engineers use angles to build bridges, roads, and other structures that can withstand weight and pressure. In basketball, players use angles to shoot the ball into the hoop. In soccer, players use angles to pass the ball to their teammates. We use angles when we cut a cake, fold a piece of paper, or even when we tilt our heads to read a book. Keep exploring, keep practicing, and keep those brains buzzing with all the amazing things you can do with lines and angles. Math is everywhere, is